Hi guys, on the forum the other day I dropped off this little idea where I started to think about, well, how can we do display methods in a way that's kind of convenient but flexible. Often we'll have modes in our application, we'll have some sort of hard mode here, a flag or something like that, constant and draw mode. The thing's drawn solid, and that will be mode 1 perhaps, and then if it's transparent it might be something else. So when we have a few of these modes here, that's all cool, but when we need to sort of customize them, you can find yourself having to do combination modes, like you might have draw mode as alpha. If we use like bits, for example, then here that would be bit 3, so it would be 4. We could combine the methods together, but what that doesn't do is it doesn't give us an option of having a particular draw order. So we can set our particular draw mode to, well, we want it to be solid, transparent, and alpha. Set all bits, turn them on. But what if we wanted to do things in a particular order? If we wanted to do the alpha masking first and then be transparent and then solid or something like that, which in this demonstration it makes no sense, but for our draw mode idea for our little masking tool, what I was thinking about is we have like a set of instructions in text, and you would just write what instruction you wanted to be done first, and then the next instruction, the next instruction. There might only be 3 or 4 different kinds of draw modes or methods, but you can change the order of those things to change the output effect. And if we have parameters, we could give each basic draw method some flexibility within itself as well. That's all fine and dandy, but then we need some code to split apart the text to understand it. The great thing about being text is we can store this inside the object as text. Load the thing in, and then the phraser understands what this is and just does that thing when we call draw. That's the beauty of it. It doesn't have to be super fast, no one cares. And considering we're only going to be phrasing a few lines of string anyway, it's not going to be that much of a problem. In fact, it's a non-issue altogether. So I started on it, and I just split this program away from the privacy tool itself to mess around with it, because I sort of haven't visualized how it was going to work, and every time I keep thinking about it, it gets more complicated to the point where you should write a complete lexical scanner. I'm thinking, no, I want to write something very simple to the point. If we take the examples up here for our example, we would have a command called image, and it has a list of these properties that we're defining or we're changing from the defaults. But it's also ideally doing things in order. So this is our file name, okay. Doesn't matter too much. The tint color, okay, we can set the tint color. We can center its handle, so its positions around the center of whatever this image is here, and that needs to be done after it's loaded. Right, or we could have like an offset of just on the x-axis, on the y-axis, or a rotational offset or a rotational scale offset, we could have like, I don't know, oops. Rotate equals 45. Now, what that would do is it would let the parent object be rotated at whatever angle you want it to be, but this would be 45 degrees in front of that. If you get what I'm saying. Or let's say it was 90 degrees, let's say, and we rotate our initial object to 0 degrees. That means that this is pointing at 90 degrees away from that. That kind of stuff. But to do this, we need a way of decoding this. So I've written a bit of boilerplate, standard kind of stuff really. We grab our text file, which I may have been making up here, excuse me. We split it up into an array. So each row is really a command with a name on it and then some brackets that represent the properties of it. That's comfortable, it's easy, no dramas. Once we have a row, we look on the row and we go, is this string empty? Does it have a bracket on it? We make simple assumptions about it. If we find an opening bracket, we look for a closing bracket, and that's the list of parameters. And we use the thing on the left hand side of the bracket. If we look at up here, so if this is the source row we're scanning, we look for this bracket here. If we find it, we then search from here up to here to find a closed bracket. There's a potential problem in that. It means that none of these properties here can ever use the character of this bracket, because it would find that and it would break our logic. But that's okay for now, who cares? Our code grabs this section of text here as the command name, and these are properties of that command name. If we run it, that's what it does. Thrilling, isn't it? Thrilling stuff. So the question comes down to is how do we decode this parameter list in such a way that we don't get broken logic. If I use in strings, for example, and just scan through and look for these space characters between these things, if I make that assumption, if a space represents the end of something, or a comma or something like that, then I've also got the issue that I can never use that character anywhere else. I don't want it to be too complicated. I want it to be something that you can just kind of type out, and so it means that the code to understand the property name pretty much has to run through and do it manually, which is a bit of a pain in the backside. So if you flick forward through a bit of code, oh, there it is, sorry. So we've found our command name, we've bumped our bracket position up, we've grabbed our params out of this, and we've got a bit of code that's doing some decoding of the parameters. So I'm initializing an array that gives us upper or lowercase. These are characters that a parameter name is allowed to be. So when we scan forward and we find something that starts with one of those characters, we just go, okay, I'm assuming that I've found, inside the parameter list, I've found a word. So I'm making a comment there. So our parameter list might be, I'll use the example up here again. These ones here. So we keep scanning forward. These are our example parameters. Params, like this kind of syntax here. So if I'm on this character here and it's alphanumeric, I keep scanning until I find one that doesn't match alphanumeric. And that's the field name. That's this name here in particular. Now once I've found a field name, then I have to look forward after that and go, what's the next character after me? So here we might just make it really rudimentary. We might go, okay, I expect the equals character to be the next character after this. So what we could do here is allow this to search through until we find an equals. Yeah, we won't do that. I'm not even calling this function, so let's have a look at this. what do we need to call this function? So I think the idea was going to be is that this is going to create an array of these keys. So we've got params there, and that P structure is what? Oh, parameters, there you go. Pretty cool. Rain's coming again, my dog's getting bored. As per usual, so am I. So I've got parameters, cut that off, don't need the type name. It'll work that stuff out for us. Quick save, let's see if it works. We don't really know if it's working or not. We're not printing anything out, so we'll head down the bottom. We're scanning through, we found our parameter name. Let's go, okay. Param name, colon plus, whatever was it? Field name. So we're searching through that row. Every time we find something that is alphanumeric, we're going to decode this as a parameter name. So in this case, it'll pick up file name, tint, that the FFFs here, so forth. They would have to be decoded for us. Yeah, that's what happens. And our position's not quite right either. So we're bumping a loop there. We don't need to do that apparently. Oh, there you go. It's grabbing not just file, but it's not moving to the next character correctly. So we're getting file, all the way through. So we're getting some false positives there. When we do the exit, of course, because loops never, yeah. So that we're exiting before we ever set the external loop counter to the new position to search from. File name, tint. That seems to be correct. We found file. Our file name is actually the value of file, so we don't really need that. I think I'll just stack the logic. You know, I don't really care that much about it. Once we've found a file name, do a length of, field name it was called, wasn't it? Field name. Yes, everyone, are you bored? And then we'll check the next character. We'll check if check if the next character is an equal sign. If it is, we'll do basically the same logic. We'll just cut and paste it. We'll probably functionize this stuff. It's probably a better way of going around it, but at this point, I don't care. Now, I'm not quite sure what character we're up to here. So loop is going to be the search position at its false position. I'll just print that out actually, just to see what we're looking at. If we go, was it param list, which is our string with our listed parameters in it. We use the current loop position there with 1. And it should display what the next character after that field name is. Right. So we don't need to do that at all. Yeah. So if the loop is, we're grabbing 2 characters instead of 1 for some stupid reason. There we go. Learn how to type. There we go. So we've grabbed our keyword. We've looked after the keyword for the next character. It happens to be an equal sign. So what's following that is going to be a word, a hex number, you know, it's going to be a word, it's going to be an integer, number, possibly a string. So we'll need quotes in there as well. So we'll need like a, yeah, if you've got like a pair of just talking marks, it'll just scan through to find the end of the talking marks and ignore the characters in the middle. It gives us enough flexibility that we can kind of hang ourselves with it. Alright, so we'll go if mid, we'll get the character value straight from the string, equals ASC equals yo. That'll get solved at compile time mostly. So we've got our field name and then we're getting our parameters after it. If we find this equals sign, then we decode some parameters. The parameter list could be different though, isn't it? It's a slightly different loop than our previous one. As we were saying before, if this character, we're doing sort of really crummy kind of lexical scanning here. We're trying not to write a lexical scanner and using this kind of logic to fall through this tree, which is always problematic. So if we assume our file name is always within a set of quotes, start and finish, if this is the next character, then it's a file name string, or any string for that matter. Yeah, that makes good sense. Because the property itself, it doesn't understand the property. It puts it into a table, and then the back end will work out that. Sorry, the back end knows what the field file will do. Wow, that's confusing. Sorry about that. So in here we have a bit of crappy logic. I don't know. We'll just try to select case. So we want the character after our current character, next character, after this one here. So we want to, well, we could move loop forward. We'll move loop forward. So now we're pointing at the next character. We want the same bit of code, param list, loop, and we'll do a select if next character. So if this character turns out to be 34 is a quote character in ASCII, I should say. Then in here we have a bit of logic that runs through. Did I close that select? No, I didn't. Put an end select in the bottom, and if we'll put a default there, say we don't understand. I don't understand. Yeah, there you go. So when it's 34, it will step through here and have a similar loop to up here. I'm really butchering this as I go through, aren't I? I could just use the end string here, and I will do that actually. So we go quote, end quote position equals end string. We're from param list from character, which is the current loop position. We want to find CHR $34, which is the quote character. If we find it, if end quote position is bigger than loop position, or is a logic fault in that already. If we don't, we're missing, missing end quote. Go to error. I normally have an abort label for these things here to get them, so it stops doing what it's doing and we abort. I'll usually go-tos for that kind of process, obviously. So we're going, bang, something bad has happened, let's stop and not do anything more. Here, I need to be comparing the string, the character after this character. Define this as a string. So we decode string. So field value in this case here is going to be mid param list from loop position to, what do we say, end quote position minus loop, and we'll print value of here, field value. So once we get into here, if field name is here, we'll specifically tell field value to be nothing. We probably should do that at the start, actually. So it's always empty once we've found something. Quick save. All right. So we fall through here. If we find that the character after our assignment character is a string character, we do an in string, checking in string to see where the end quote is. If there is one, we grab this stuff. Here's the value. And if we do find that, then we set loop after this value, end quote position. Now we actually want to continue the main loop here. Yeah. So it's going to branch out of here to our next statement and keep this main loop running. We've broken something. Oh, wrong mid. We have a mid that does character retrievals and a mid that does string retrievals. Missing the closing tag. Closing. There you go. I don't understand you. Good. Excellent. Yeah. Because I think I changed... what character did I set this as? I didn't. What if we just use the... Yeah. We'll let you use both. Just to be nice. If we do end quote character, $CHO next character. What this will do is it will use, if you use the double quotes or the other quote, or whatever characters we want to put up here to denominate as being wrapped around a string, and use this, it'll search for the matching end quote of the same type. Let's have a look. Wow. I don't know if you can see that or not, but so we found file, we found the equals, and we've got a value of file name. We're the one character in the wrong position. Then we found tint, and it doesn't understand what this is because there's no this dollar sign has no decoder. Cool, no worries. So here we should we'll bump a loop forward. So we're checking from the end of this to the end of that. We're going to get the end of that. We might need to trim that as well. No, we're fine. So we've decoded the file field, it understands the equal statement, and that this part here is a string. So tint it won't understand because it doesn't know what this dollar sign here is. What we could do is when we see a hex statement like that, we run through and we compare, we just scan the next characters to see if they match a hex value. That's it. So until we find a space or something like that towards the end of it. So at the moment it doesn't do anything with the values, doesn't care. Decode a string, we'll put like the support for a hex value in here. The dollar sign, you know, hex value. Yeah, okay. We're going to end up with a bunch of these search loops inside search loops, which I don't really, not that keen on, but we'll try and get that to work. So we're searching from the current location of this dollar sign. We need to convert all that stuff there actually. Often I have these as functions and just call out the function to decode this thing. We're searching through this part of the string here. We want to know if this is a valid hex character. And up in here, I just thought this might be a neat idea of one. So Fraser is its hex character. So I can tag. This is how lazy this has become. Yeah, so we want to tag A to F. These are valid. So they're all valid characters, and the other ones are the numeric characters. Where are we? 0 to 9. Oh, I'm gonna get caught that one there. So it gets rid of the internal comparisons that would have to do, you know, are we lowercase a, uppercase A, or numeric characters? We just have a simple table. I'm going to look at the table to go, yep, you're a valid hex character, you're not. Here, just replace this. We're looking for when it's false. When it's false, we get field value. And we might have some determination there about what this thing does, but maybe not. So we print the value out if it's that, get this thing here. We step forward in the loop, we continue on. We've done this. We should continue. We've decoded that. Let's try it out. Hack and slash this thing together. Field value, that's not the right thing there at all. Something's broken. Oh, that's weird. So it's going value, 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 value. So we've got some broken logic in there. Okay. Hex. Just make sure we're decoding the right thing. Or I think we're decoding the right thing. Sometimes you never know. Keep searching there, it's all good. We don't exit this loop. That's why. So once we've been scanning across of the characters that are in the hex string, we have to get out of this loop here, and we're escaping this case statement here as well. So before we were locked inside this loop here, scanning for hex values. That's why we're just dumping out these values. That's better. That's better. But we didn't print center handle. I'll just check loop. That's the end of when we're decoding the hex value. And param list size. Just curious as to where that loop value is. That's well inside that. It's fine. Alrighty, we've basically got this thing to work. It's pretty clunky. You won't hear any complaints about from me about that sort of assessment. It certainly is clunky, and I think we've got some logic problems tucked away in it as well. What happens if this is not equal to that? Nothing. Good. Got our file name, decode our string, we've got tint, we've decoded our hex value, but we haven't got our center handle. Now, is it just not displaying that, or are we doing something weird about that? I think we might be doing something weird, because this logic here only works if we decode a character at the end of this row that fails to be alphanumeric. If we keep scanning through this loop and they're all alphanumeric, then that's going to be... What I might do is I might just cheat. God forbid. I might just add to the end of the parameter list here, let's add a couple of just spaces to the end of it. And what that'll do is it makes, we don't need any logic inside those inner loops to pick up those circumstances. Oh, sorry. I wanted to add those to it, not replace that. There we go. So it's decoding the file name, we're getting our string value, we're decoding our field called tint, we're getting our hex value decoded, and our center handle is being decoded with no assignment after it. So if I put something after that that's either a hex value or a string, we need a space. What? RGB equals, you know, a purple color. Quick save, right? We should get that in the list. Yeah, there you go. There you have it, dudes. So shaping up, we can make something sort of useful out of that, and hopefully you get some ideas of how to, you know, create your own text formats and phrase them and use them to be more flexible and powerful in the long run. We'll leave it there. Thanks for watching. Have a good time, and I'll see you next time. Bye.